In this video, we want to talk about how to calculate the oxidation number of any element and also how to name complexes, that's coordination compounds. Let's begin by stating the rules that follow the oxidation number calculation. The first one is that any free element, which is any element that is uncombined, its oxidation number is 0. What we mean by that is that if we have something like lead, magnesium, or even calcium, any element, since they are uncombined, their oxidation number is 0. The next rule is that for monoatomic ions, monoatomic ions, their oxidation numbers is +1. For example, or you can say that the oxidation number is the charge they carry. For example, if I have something like lithium ion, its oxidation number is +1. The next rule says that for all group 1 elements, the oxidation number is +1. For example, this lithium ion, its oxidation number is +1. Sodium, its oxidation number is +1, and so on. The next thing likewise is that for group 2 elements, the oxidation number is +2. So if we have something like magnesium, we have something like calcium, and so on, their oxidation numbers are +2. So the next rule is that for halogens, that's the group 7, their oxidation number is usually -1. So if I have something like fluorine, if I have chlorine, if I have bromine, all of them, their oxidation numbers are -1. And also for hydrogen, hydrogen is usually +1 when he is with metals, when he combines with, non-metals. Then he's usually -1 when he combines with metals. For example, sodium hydride, when metals, he is -1. The next one is that when we have oxygen is usually -2, except in peroxides. In peroxides is -1. So let's begin. The first one we want to calculate, let's calculate for sulfur, the oxidation number of sulfur in this compound. What we simply need to do is, sulfur is group 1 element, so 1, and he is 2 in this, so we say times 2, plus the oxidation number of sulfur that we want to calculate, plus the oxidation number of oxygen. Oxygen is always -2, multiplied by the 4 that we have here. All of them must sum to 0, so the sum of the oxidation number of any compound must be equal to 0. So what we're going to do is, here is 2 plus S plus -8 equals 0. So here we have that X -6 equals 0. Therefore, sulfur is +6. Remember, the plus must be there. So you can call this compound sodium tetraoxosulfate 6. The next one, let's calculate the oxidation number of carbon in carbon 4 oxide. What we still need to do is the oxidation number of carbon plus oxidation number of oxygen, which is -2 times 2 equals 0. All of them must be equal to 0. Now, C minus 4 equals 0. Therefore, C equals +4. That is why it is called carbon 4 oxide. What this thing means is that oxidation number tells us about the degree of oxidation, that is the number of electrons gained or lost. Let's find the oxidation number of chromium in this compound. The oxidation number of potassium is 1, is in group 1. So 1 times 2 plus oxidation number of chromium plus oxygen is negative 2 times 4 equals 0. So what we'll have is 2 plus chromium minus 8 equals 0. So chromium minus 6 equals 0. Therefore, chromium equals plus 6. So let's find the oxidation number of chlorine in this hypochlorite. What will begin with oxidation number of hydrogen, 1, plus oxidation number of chlorine that we're looking for, plus oxygen is always negative 2. Oxygen is always negative 2 times 4 equals 0. So we'll say chlorine plus, here is negative 8, this, so plus negative 7 equals 0. Therefore, chlorine minus 7 equals 0. Chlorine alone becomes plus 7. The next one is to find the oxidation number of manganate in this compound. This is 2. That's 1 times 2. Is 1 times 2. So 1 times 2 plus oxidation number of manganate plus negative 2 times 4 equals 0. Here is 2 plus manganate minus 8 equals 0. So manganate minus 6 equals 0. So manganate equals plus 6. So let's feel free to pause the video, find the oxidation number of iron in this compound. Feel free to pause the video and try it out. We can solve and see the oxidation number of iron plus chlorine is always minus 1. So minus 1 times 3 equals 0. So we have iron minus 3 equals 0. So iron equals plus 3. Let's find the oxidation number of chromium in this compound. So this is 1 times 2 plus chromium is into 2 plus negative 2 times 7 all equals 0. Now this is 2 plus, since this is 2 times of the chromium, negative 14 equals 0. So here we have that 2 chromium negative 12, that's this and this, negative 12 equals 0. Therefore 2 chromium is equal to plus 12, and only 1 chromium becomes 12 divided by 2, which is plus 6. This question now, let's find the oxidation number of carbon in this compound. Remember, this has a charge of negative 1. So what we're going to do is we'll say the oxidation number of hydrogen, which is 1, plus that of carbon that we're looking for, plus oxygen is always negative 2 times 3. All of them must be equal. The total charge, which is negative 1. So what we'll do is 1 plus carbon, negative 6 equals negative 1. So it means carbon, negative 5, is equal to negative 1. Therefore, carbon becomes negative 1. This crossing, minus 5 crossing over becomes plus 5. So carbon is plus 4. Likewise, let's find the oxidation number of chromium in this compound. So we can have 2 times that of chromium plus oxygen is actually negative 2 times 7 equal to the total charge, which is negative 2. So 2 chromium plus, or let's just go straight and say negative 14 equal to negative 2. Therefore, 2 chromium will be equal to negative 2 plus 14. Therefore, 2 chromium equal to plus 12, and only chromium becomes 12 divided by 2, which is plus 6. So let's look at another one. Let's look for the oxidation number of chlorine in this compound. So here, feel free to pause the video and try it out yourself. So you can see that chlorite is produced when chlorous acid is dissolved in water. So if we have chlorine, oxidation number of chlorine plus that of oxygen is -2 times the 2 that is here equals the total charge -1. So we can have that oxidation number of chlorine -4 equals -1. So oxidation number of chlorine equals -1. This crossing over plus 4. So chlorine equals +3. Now let's take it a step further. Let's find the oxidation number of chlorine in this compound. Let me use this for example. This is 6. So now you can see that this is an ion. So the sum of the oxidation state is equal to the charge that is on the ion. There is a shortcut to find this. Anytime a metal atom is surrounded by electrically neutral molecules like water or ammonia, you need to know that the sum of the oxidative states in the attached neutral molecule must be 0. So this neutral molecule, water, must be 0. Because of that, we can ignore it and say that the oxidation number of chlorine is equal to +3. If we look at, for example, this coordination compound, you can see that from here to this place is the coordination sphere. So if this is the coordination sphere, this is the central ion, which is cobalt 3+. You can see this is the ligand, this and this, the ammonia and the chlorine ion, they are the ligands, and this is the change number of complex cation. This is the ionizable anion, and this is the coordination number 4 and 2, which is 6. The coordination number of this is 6. So cobalt has the coordination number of 6 in this place. So let's look at some of the rules first in naming coordination complexes. Now, the first one is that if we have that the compound is ionic, then we will have to name the cation first. If we name the cation first, then we can name the anion. The second rule is that we name the ligand followed by the central metal. So we name the ligands alphabetically. The negative ligands, which is the anions, have names formed from adding O in their names. For example, we can have iodo, we can have chloro. So we add the O into the negative anions. If it's cyanide, we have cyano. So the O we have to come in. Okay, for neutral ligands, the same name, the name given to them is let's say, for example, if we have water, we call it aqua. If we have amine, that's ammonia, we call it amine. If we have CO, we call it carbonyl, and so on and so forth. So let's say, for example, let's look at this particular compound to name it using these rules. You can see that amine is 2. So we can say diamine tetrachloroplatinum 4. The oxidation number of platinum here is 4. So we can say diamine tetrachloro, then platinum 4. That's how we can name this. Let's look for more rules. If more than one ligand of a given type is present, then the number is indicated by the prefixes. We use di, like here now, 2. Di for 2, tri for 3, tetra for 4, penta for 5, and so on. Now let's look at another example. For example, when a complex is cation, let's see CO NH3 6, then Cl3. Now you can see that this is neutral and this is -1 into 3, so -3. So if it crosses equality sign, so cobalt is actually +3. So if here now we want to name it, you can see that we can say hexaamine cobalt 3 chloride. Hexaamine cobalt 3 chloride. Let's look at this, for example. Feel free to pause the video and try this for yourself. Okay, since this is neutral, it means that silver is +1. So if silver is +1, we can say diamine silver 1 ion. So let's look at another example. Feel free to still pause the video and try it for yourself. You can see this is neutral. The oxidation number of chlorine here is +3. So we can say tetra aqua. Let's write it down. Tetra aqua dichloro chromium 3. Chloride. So now feel free to pause the video and try out this one. Wow. You can see that the oxidation number of nickel here is 2 because this is neutral, is +2. So you can name this by saying diethylene, this ethylene diamine, there's ethylene diamine is 2, diethylene diamine nickel 2. Feel free to share this video, and if you have not subscribed to our channel, hit the subscribe button. Thank you.